Here we've got a few examples from section 7.5. Now in 7.5, we look at some rules associated with inverse trig functions. I'm not writing out all of these rules for the purpose of this video, but rather our focus here is on using those rules in a few specific examples, and you can refer to those rules as we go through this. First example is simply asking us to find a derivative, and it's asking us to find the derivative of the inverse sine of 2x. That's our function. And so when we take the derivative, we're using our new rule for the inverse sine function along with the chain rule, because we have this inside function 2x there. So a mistake I sometimes see students make in this type of example is they forget that factor of 2. And that factor of 2 there is really important, because that's what indicates to me that you understand that you're using the chain rule here. Okay, that's the derivative of the inside function. So we're substituting that 2x in there in place of where the inside function will go in the derivative expression, but we also need its derivative there too. Let's move on to 77. 77 also involves that same rule in the antiderivative form. And we're given that rule in the form of 1 over the square root of a squared minus x squared. Okay, so we have something in that form. We need to identify what a is. A here is 5 because 25 is a squared. And we're going to make a positive whenever we do this. We've got 6 inverse sine of x over 5 plus c. Here's one more that uses the antiderivative rule involving the inverse tangent. Now here we need to do a little bit of work to get it in the form that we're looking for. Let me move ahead a couple steps and then we'll move back. We want something that looks like 1 over z squared plus a squared. That is the form associated with the inverse tangent in terms of these antiderivative rules. So we don't quite have that because we have that 16 in front of the z squared when we began here. So to begin with, there's kind of 2 paths we could take here. But the way that I went through this is to factor out the 16, bring it entirely out of the interval, okay, using our constant multiple rule. We can also bring that 2 out, so that's why the 2/16 became 1/8. And I rewrote this 25 over 16 as 5/4 squared, because remember, we want to think in terms of a squared. And then from there, it's plugging into the formula. So we've got a factor of 1 over a here, a factor of 1 over a here. And since a is 5/4, 1 over a is 4/5. We still have that 1/8 out there. I multiplied, and we end up with 1/10 inverse tangent for x over 5 plus c. I mentioned that there's kind of 2 approaches we could have taken, and I'll just mention the other one, and if you want to check that, that'll give you the same answer or an equivalent answer. I'll leave that to you to decide if you want to go through that process. What we could do is a substitution here. So instead of factoring out the 16, we could say, well, why don't I take that 16z squared and think of that as my new variable squared? So if I let u equal 4z, then that substitution would also lead us toward an inverse tangent antiderivative at the end, and it should be equivalent to this. I prefer this way personally, but either way is certainly a valid approach. I hope you found these examples helpful. This is the last section in this course. So I hope you found these videos in general helpful. And that concludes our videos for this course. Take care. Bye-bye.